Okay. Well, we're going to talk about DNA misconceptions. This is probably about a 20 to 30 minute little chat, but one thing that I've noticed having taught a number of different DNA groups, and in addition to that, some courses, some seminars, some full day events, there are plenty of misconceptions to go around. And I also kind of crowdsourced at work and asked if anyone had anything to add that they thought was a misconception. And so after we get done with this recording, then we'll probably turn that off and do some discussion on this. So siblings share the same DNA. I hear this quite a bit. People ask me if I have a sister or a brother, why do I need to test them? They have the same DNA as I do. That is partly true. They do have 50% mom, 50% dad, and some overlap with you as a sibling, but they're not the same 50% unless they're identical multiples, so identical twins or identical triplets. If that's the case, then yes, you wouldn't necessarily need to test both. Although I will say that having tested both of my identical twins, what I've found is that they have slightly different ethnicity reports, and there are differences in their match list. Not great differences, but some. So some of it has to do with when they tested, how recently they tested, if there was a gap between the testing, but the ethnicity estimates, that part doesn't surprise me, that there's some slight differences. I've also heard people question if they're siblings, if people think that all siblings have the same DNA ethnicity estimates, and that's not necessarily true. I have 3 children, and on the left is my daughter, and you can see her percentages there. I think these are the most recent ones. They just rolled out some the other day. And then Casey and Corey are on the right. They're the identical twins, but you can see there that their ethnicity estimates are slightly different. And part of that is because of the word estimate. There are a number of different ways that the companies determine ethnicity, and they do sampling. And so they may have sampled Casey in one spot and Corey in another. So they are close, but they're not exact. And you can see here that even my son Casey has an Ireland that's not showing up at the same level, and Scotland not at the same level, but they're close. And you see Casey has Sweden and Denmark, and Corey doesn't have that at all. So, and they are identical twins, I promise. They were the same amniotic sac. So they are definitely, even though they're 34, I know for certain that they're identical twins. Your ethnicity matches will match your known estimate or your known genealogy, which is not always the case. How many of you have opened up your ethnicity and you're thinking, well, that's not right. Doesn't match what my paper trail says. We have a project that's going on at work where someone was talking about a new word that I hadn't heard before, and that was mestizo. I think I'm pronouncing it correctly, but in Latin America, that's a person of mixed race, and sometimes it's indigenous, African, European. It's kind of a mixture, Asian sometimes. And so I put here my daughter-in-law's ethnicity estimates, and she is Mexican, and you can see that she's about half indigenous American, and the rest a mixture of Europe, and also Africa, and also a little bit of Asian as well. So, and just in case you didn't know, Iran, Persia is considered to be Asia. And so this is an interesting concept that I run into all the time when I'm doing presentations, and people ask me questions and they say, you know, this is wrong because I know. Well, I know something. We've all been experienced enough by now to realize that what we think we know about our family isn't always correct. And I've even experienced this in my family several times, but probably most notably as a grandfather that I thought was my grandfather biologically who was not. And so they're very similar. Both grandfathers would have been very similar in their ethnicity, so nothing really jumped out at me, but I know that some people find that sort of thing out by ethnicity. And remember, they're estimates. All your ancestors' ethnicities will be in your ethnicity report. This is another misconception that I hear quite a bit, but there are a lot of things that determine the ethnicity estimates. Remember that word estimate. They're sampling, different companies sample in different ways. Population genetics is involved in this, so it has to do with how many people are in the database, what's represented there. There are reference populations that vary from database to database. And we've done some in the past about GEDmatch. I haven't really done a lot with GEDmatch recently, but when I had an account there, we looked at admixture one time, and the admixture there has hundreds and hundreds of different reference populations. So depending on the company where you test, you can have varying results. There are a lot of over and underrepresented tested groups, particularly in the US databases. You know, we tend to have certain groups in our databases and others that are underrepresented. Recombination always impacts your ethnicity report. So over time, you have less and less of those ancestors' DNA that are further and further back. And of course, our ethnicity estimates are in the same general genealogical time frame as our ancestry DNA or autosomal DNA. So it's really 4th to 5th great grandparent range. And those estimates hold pretty well. I've heard Blaine Bettinger talk about how they're accurate at the continent level and not so much at the country level. And so just keep that in mind when you're thinking about misconceptions. There's no way to guess how closely two men are related and why DNA testing. That's a common misconception. It's not easy to figure out, and there is kind of some guesswork and involved in that. But if you look on FTDNA's page where they describe the Y-DNA STR matching, you can come up with some amount of relatedness using a chart like this. And they do have some information on this, some white papers to support this. And so I just wanted to let you know, if you do have Y-DNA matches and you can compare kit to kit with someone else, same level of testing, you can kind of infer some general age ranges on how long that it might be that those matches are related. So whether it's in a genealogical time frame or not, whether it's 15 generations, so not too easy to use or figure out. And of course, all the big Y testing is just incredible. I feel like every day there's something else I learn about big Y testing, block trees, and all that kind of stuff. It's just crazy how much is coming out about that. So as more and more men are big Y tested, and you're looking at private variants and how men are related, I think we're going to learn more and more about this. Sometimes people talk about small segments. There's kind of a debate right now in some genealogical circles about this and whether or not small segments are reliable in terms of DNA testing. If you want to use small segments to determine most common recent ancestor, it gets really tricky, and the amount that you can learn from those small segments over time as you go back in time is less and less. On Facebook, in Blaine Bettinger's group, Genetic Genealogy Tips and Techniques, he does a lot of teaching on this as people post things, as people ask questions, and really talks a lot about the peril of small segments, not to really place too much in that small segment range in terms of what you can infer from it. And the further back you go and the smaller the segments are, and the more ways that you can be related to someone in multiple ways, it really makes sense to start in the higher relationships rather than the lower. Sorting and filtering. I hear people kind of confuse these two, so I wanted to talk about this one for a minute. But sorting, some people think sorting and filtering are the same thing when it comes to your match list. But sorting is dividing up your shared matches into groups. And we did that a couple times last year when we talked about clustering tools, leads method, some of those other sorting methods. And we made spreadsheets and all of that. And if you missed some of that, go to YouTube and watch and maybe learn a little bit more about how you can sort your matches and learn how to cluster. But sorting is just dividing up shared matches into groups. And those groups correspond to either 4 grandparents, 8 great-grandparents, depending on how much you know about the tree and how much you can tease them apart. But filtering is a little bit different. Filtering is choosing a DNA match to a particular line and then using that to remove other matches from consideration, to either like rule them out or rule them in. So I believe it was Jamie talking about using a DNA kit from a targeted tester to rule in or rule out a hypothesis. So it's similar to that when you choose someone to target test or you find someone in your match list. So you can filter someone to remove the maternal matches. And then you can filter to remove the maternal paternal so that what remains is the paternal paternal. So what you're doing is kind of a process of eliminating. So if you're looking for that unknown paternal grandfather, the male pat, as I like to say, then you can filter out all the mother matches, the maternal matches first. And then you can filter out the paternal maternal matches in order to get what remains. And so filtering is slightly different, but you need the sorted groups in order to do that. So they go hand in hand, but they are different concepts. We're going to talk actually about filtering the next couple of months when we go through the case study. There is some confusion about triangulation, and again, Blaine Bettinger posted about this on his Facebook page, and there's kind of a broad definition of triangulation, but there's also a narrow definition of it. And so I wanted to make sure that we talked about this for just a minute. Triangulation, if you look, I have a kind of a screenshot of chromosome 3 in a browser. I believe it was at MyHeritage, where it shows that 3 people share a segment in common, and then MyHeritage tool circles it. They put a ring around it so that you know it's a triangulated segment. And triangulations when 3 or more people share a segment, and it can lead you back to an ancestral couple, but technically it's not triangulation if all 3 people inherited this from the same close ancestor. So triangulating, if you look at the diagram kind of at the bottom, where it has one line with a great uncle and a second line with a grandfather and a third line with a great aunt, if you have along the bottom row people who have triangulated segments, that's technically what triangulation is. They're not all descendant from the same person. So the tester, the sister, the father, the grandfather are all having the same piece of DNA. So it doesn't necessarily, I mean, obviously it proves relationship, but it's not the same thing as proving the most recent common ancestor of the great grandmother. So that's kind of a nuanced thing, but I did want to mention it. And if you want to learn more about that, Blaine has some postings in his Facebook group about that, but I thought that was an interesting thing to point out. FTDNA and 23andMe and haplogroups. Let's talk about this for a moment. A lot of people use their haplogroup at 23andMe, their male haplogroup, their Y DNA haplogroup in the same manner that they use it at Family Tree DNA. And 23andMe is an approximate haplogroup. Maybe approximate's not quite the right word, but it could be upstream or downstream from where Family Tree DNA places that haplogroup. The testing at FTDNA is very much more specific. So when you talk about haplogroups, there's a link there for genetichomeland.com, and you can figure out if one group is upstream or downstream from the other. So the way that I use the information at 23andMe is to determine if someone's upstream or downstream from someone at Family Tree DNA, but also I use it to rule out. It's kind of a tool that I use to rule out two men being related rather than assume two men are related, if that makes sense. So if you see two haplogroups and maybe one's an R and one's an E, and 23andMe is one of those kits, you know that they're not related. So it's something to consider, specificity. And if you really want to do Y testing, you really probably need to do FTDNA. 23andMe ancestry composition, there's a lot of confusion about this, and I have to admit this is something that for me was not intuitive when I was first learning to use the 23andMe ancestry compositions. This is a chromosome mapping of ethnicities, if you're not familiar with this. So if you have a test at 23andMe, you can go to your ethnicity or ancestry composition, part of that tab, and you can see the chromosome mapping. So what this shows you is chromosome 1, chromosome 2, and so on. How are you related? And what are the ethnicities that are on here, presumably from your parents? And one of the things that took me forever to really wrap my head around is that, you know, like all of the top ones are not the same parent and all of the bottom ones are not the same parent. This is a really good example of how the chromosome painting works. If you look at the orange line, that's the Asian and indigenous line, Japanese Korean is the actual official subgroup there. So if you look at that orange on chromosome 1, that's a whole chromosome 1, a whole chromosome 2, but you see how it's the top and then it's the bottom. So the top and bottom don't mean anything. It still is coming from the same parent. European is the other half of this person's ethnicity, and that's the blue. And probably a lot of us are used to seeing different shades of blue for Northwest European, UK, that sort of thing. Mine is almost completely blue, all kinds of weird blues. So this is something to keep in mind when you're looking at these. One other thing to look at is the X at the very bottom. You can tell here that this is a male because there's an X and a Y. The Y is not mapped, but if it were female, there'd be 2 X's, right? So what do you know about the X inheritance? You know that this man inherited the X from his mother because he got the Y from his father. So his mother is the Korean. So that does give you some information. But remember, the parts of these chromosomes, they're not mapped like the top one's mom and the bottom one's dad. There's no pattern to it. It's just one chromosome is this, the other one is that. If you look at mine, the next slide is mine. I just isolated here for French and German just to kind of prove a point. I have 7.5% roughly French and German. And if you look in chromosome 1, do you see how it's the second chromosome 1, second chromosome 4, and so on? But look, it's first chromosome 18. What does that mean? Well, does that mean that I got those from one parent? I got them from both parents? I don't know. It could be either case. So it could be that I got some of it from mom, some of it from dad. So that just depends on how much I've investigated my Family, maybe I've mapped the chromosomes in DNA Painter, so I know more about it. But whether or not they're on the top or the bottom doesn't tell you whether it's mom or dad. And even within the bottom one, it doesn't tell you that that's all the same parent either, because I could have gotten some from mom and some from dad, and it's all on the bottom. So it jumps around. The surname trap, all the time, this one comes up. When I'm talking to people, two people are DNA matches and one has reads, the other has reads, so we're related through the reads. This is a really common misconception, and it's going to probably land you with some brick walls if you're assuming that surnames mean where the relationship comes from. It could be that, and of course, the closer the matches, the more likely that is. If it's first cousin or first cousin once removed or half first cousin, it's likely that's the connection. But if the matches are more remote, you need other evidence to build your case. It might be that reads and reads and reads everywhere are related, but you could be related to someone else on another line, or you could be related through the reads and a second line. So you're going to need to prove those relationships, look at the centimorgan values, the generations, and a high percentage of my 4th to 6th cousins are related to me more than one way. And I don't necessarily come from an endogamous population or even pedigree collapse. But what I have is I have a lot of ancestors who had similar arrivals to the US, similar migration patterns. They kind of crossed paths with one another over time, many times. And not all reads are related to one another. So that's something to keep in mind as well. So surnames are a hint. And again, when we do the case study over the next couple of months, we'll talk about how I use those names for hints, but that's not proof. Just because you have a read and I have a read, it doesn't mean we're related through the reads. The relationship category provided by the testing company is the actual relationship. So if I have a cousin and she's in the 1st to 2nd cousin category, what does that mean? Does that mean she's my 1st to 2nd cousin? Well, maybe. If you click through Ancestry's charts and everything, how do we estimate the DNA relationships is what it says on screen. What you'll see is there are percentages that are tied to different categories of relationship. And this is based on a number of different things. It's based on specifically Ancestry's algorithm, and each testing company has their own. It's based in part on values provided by the Shared Centimorgan Project and where those curves overlap one another so that there are multiple relationships. So there's a lot of science behind it. And if you're interested, there is a white paper about that as well. Ancestry, if you just Google Ancestry white papers, you can find the research that supports most of the things that they have in their company tools. So this relationship with this particular 1st to 2nd cousin happens to be 1st cousin once removed, because I've actually built the trees and figured out who she was and worked that case. But that's the lower percentage option. It's the 26% option, not the 74% option. So, but all of these relationships are possible given that she and I share 658 centimorgans. So just because the categories 1st to 2nd cousin, it could be that she's a half niece, so, or a great aunt. So there's lots of other options for the relationship. I've made this mistake before. How many of you made the mistake of assuming a full relationship in your match list instead of a half? Because this has happened to me. Part of the problem that I have is I spend so much time working on DNA for work that I don't necessarily work on my own list. And so every once in a while, I'm kind of caught off guard that one of my cousins isn't really a full cousin, it's a half cousin. And then I spend time trying to figure that out. So I have a cousin that I share 553 centimorgans with, and the higher probability is that's a half first cousin. The lower probability is a first cousin, full first cousin. But actually having, again, worked the trees, figured out the common grandparent, one grandparent, not two, this is my half first cousin. So don't always assume a full relationship. Assume the half relationships are possible. If you use the Watto tool on DNA Painter, we haven't really done a session on that because it's a pretty advanced tool, I think, for most people to kind of wrap their head around. But if you use the Watto tool, I love the fact that it gives you, it generates hypotheses based on full and half relationships. So it does take that into account. Everyone adopted knows they're adopted. This is a big misconception. There are many, many people out there who are adopted and don't know it, are sperm donor conceived or egg donor conceived or both and don't know it. And so sometimes when we're corresponding with our matches, if they happen to reply to us, we need to really think about how we can approach people without judgment, without spilling the beans, so to speak. Be careful how you interact, and you know, it's an ethical dilemma, I think. If you know that someone's adopted or you figured that out and maybe they potentially don't know yet, what do you do in those situations? So there's a lot of things that are involved in that, and you just can't put that cat back in the bag. So you want to make sure that you're thinking about that as you're corresponding with people that they might not know. Probably one of the biggest misconceptions of all time is that my family tree is correct and everyone else is wrong. I encounter this all the time. I've even thought this about my tree, and all it takes is one misattributed parentage event to cut a branch off your tree and you got to start over. So I think a lot of us in this group have been there. I certainly have more than once. There are some misconceptions about investigative genetic genealogy, and I've just listed a few of them here. There's an article associated with this if you want to get this from the recording. I can send the PDF of this article, but I thought it was a really great overall view of investigative genetic genealogy and what happens when law enforcement is involved in it. There are a lot of misconceptions about what law enforcement's allowed to do. And I know this is a lot of text on the page, but it's the last kind of thing that I wanted to talk about tonight. So I'll send you guys that article in email and you can be familiar with that. So when I send the recording, I'll send that to you. So I'm going to stop the recording.